We'll see how it goes. I don't know
Hold
if it's
on,
trouble or not. We'll find out. I don't know if Google Classroom has an upload limit. Is my only concern currently. All
Is
right,
this
so
the Rocketbook?
yeah,
Cool.
I was gonna use the boards, but I could use the Rocketbook and then scan the pages and upload them for y'all. So I thought that would be easier.
Oh yeah.
So 9.2 is series and convergence. I actually found erasable markers, so that's why I went ahead to use the Rocketbook. So this goes back to things that are in like algebra 2 and pre-cal. So you have this idea of like infinite series. And with infinite series, you can look at the summation from n equals 1 to infinity. And then you have a sub n. And it starts, obviously, you do 1, then do it for 2, then 3, and go on and so forth all the way to a sub n and onward.
Is that n equals 1 down below?
Yeah, sorry. I need to write a little bit bigger. That's okay. So if you look in the textbook, it talks about definitions of convergent and divergent series, which is something I mentioned in 9.1. They don't really do a good job of mentioning either of them. They just go, "Hey, this series convergent, this series divergent," and they don't really give you um, a reason for that happening. So if you look there, they mentioned that you do partial sums, which we're going to do couple problems, but basically you would parse this out and look at a sub 1, then a sub 2, then a sub 3, and go, okay, well, if these things are happening, this is what a sub n looks like. And we'll see that in a couple problems. Um, and it lets you know that if the sequence of partial subs converges to S, then the series converges. So if it's moving to a certain point, then it converges. But if you're just going off to who knows where, then it diverges. So that's similar to what you saw in 9.1, where you talked about if you're converging to like 1 or 0, but like if it went to infinity, it would diverge. So that's not much different. So they have an example of a series here. So, and then, so the series. And if I need to write larger, just let me know, because I know it might be a little bit hard to see.
Ooh, that size is good.
Okay. We have n equals 1 to infinity of 1 over 2 to the n equals 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 to infinity and beyond.
So are they all going to look like that with the infinity up top and the n equals 1 at the bottom?
For infinite series, yes.
So it'll always be equals 1?
Yeah. Well, they could start it down here. They could start it anywhere else, but like more often than not, it's going to be n equals 1 to infinity. Just based off like they want you to look at the first term and then go from there.
Okay.
And then so when we talk about partial sums, so it has the following partial sums. And this is what I was talking about. Like they'll separate this out and look at, well, if I look at the series of, so if I do, let's look at what S1 would be. Well, S1 is going to be 1 over 2. And then if I look at S2, that's going to be 1 over 4. S3 equals 1 over 8. All right, where you see the same like it's just breaking down the pattern. Oops, I messed up. I lied. Don't listen to me.
What?
I lied. Sorry. I realized it when I said it.
We don't write in pen. I don't have whiteout now.
Well, I'm sorry. I realized it once I said it. I was talking about series and not a sub n's. All right. So S1, like the summation of a sub 1 is just 1 over 2. If I do S2, which would be the first two terms, I end up with 1/2 plus 1/4.
Oh, so as you go up, it'll keep like adding them.
Correct. So like this is going to go to 3 over 4. And then here I have 1/2 plus 1/4 plus 1/8, which is 7/8. Does that make sense? And really, you can tell from here I'm getting closer and closer to what?
Infinity?
Nope.
One.
One. Because.
Go. Y'all are smart. Take me a minute.
And there's a way to break this down. And like I said last week, it might be worth going to look at different sequences from before and breaking this down. What's up? His homework? Yeah, I had him do it when you're out the...
He told me he already had snacks, and I was like, what?
Yeah, I told him he had snacks, and then I told him he could do his homework. And then is he doing his light bright now?
Yeah.
Okay, good. So, and then we could break this down into S sub n, which is going to be 2 to the n minus 1 over 2 to the n. And this is one of those things, like, for this, go back and look at infinite series. Geometric. That didn't fit. And arithmetic. Because those are the three things you're going to see within 9.1 of this section, is going through and looking at these 3 different types of sequences, among everything else. But this might give you some clarity of what's going on with the actual problems. So how they go from like this to this. Does that make some sense?
Kind of.
Okay. I'll try to get you guys some links to those, and I will... Here, let me do this so I don't forget. Let me ping myself in our own channel. Get series and sequence notes. Because that will help, because we've been doing that anyway in there. So if I can get some notes from them, I think that'll help you all.
So you got that SN thing from the S1, S2, S3?
Yeah. Yep. And you guys have, like, because there's a pattern recognition thing where you choose, like, A sub n, and then you go, okay, well, A sub n is 2 to the n minus 1, and then I just minus 1, and I place it over what A sub n is. So it's one of those things, like, I think we need to be able to go back and look at those properties and see how they work. So I'll do my best to ask pre-cal today and see if someone will give me their notes, and I'll post them on Classroom for you guys. And then I will also maybe find some resources for us for that, because I think when you go from the dual pre-cal class where they don't talk about series at all to this, you haven't seen series basically since Algebra 2. And I don't know how they went during Algebra 2. Like, did you guys spend a lot of time there? Did you not? I have no idea.
No, we didn't really. I don't think we did that really.
Okay.
So do we have to know how to do that specifically for like quizzes and tests and stuff?
Like if you don't have this, I'm not on the struggle bus right now. Like, that's not a huge concern to me. My main concern is just having an understanding of what's going on. Like, understanding that, okay, this is moving to 1, so converges at 1.
Okay, so if it's going towards 1, it converges at 1.
Right.
So whatever n equals whatever. So whatever that number is, that's where it's converging.
Right, because, well, here, like, what this ends up doing later is you have the limit as n approaches infinity of, they write it as 2n minus 1 over 2 to the n. And we know, bless you, we know that's going towards 1, just based off of partial sums. So really, like, if you do this, you know what the answer is. Like, this is just extra.
Okay. So basically, whatever that little n equals whatever, that's where it's converging towards.
No.
Darn. What the, oh.
No,
Wait.
because Mackenzie, right? Think about this. If I ask the same question but I say I want to know from n equals 1 to infinity of 1 over n. Where's that going?
Infinity.
Nope.
I don't know. I just threw that out there.
If I plug in, if I'm looking at this, right, and I go through, each time I substitute something in, right, I'm going to have 1 over 1. And then I'm going to have 1 over 2. And then I'm going to have 1 over 3. And then I'm going to have 1 over 4. Really, I guess I should have said from 2 to infinity. But whatever. We know this 1's out here, but if we ignore this for right now, if I just had a bunch of fractions and they kept getting bigger, I'm converging to 0 if I ignore this 1 over 1 at the beginning. So like this doesn't necessarily determine what you're going to, what you're converging to. This is just your starting point. Like that's where you're starting your series.
Oh, so it's either 1 or 0? Is it like, or can
Well,
it be any?
it could be any number.
Oh gosh. Okay.
Cause like in this case, right, where I'm doing this, I'm really converging to, eventually, I'm really converging at 1 if I keep the 1 over 1 there.
Okay.
Okay, does that make more sense?
I think so. So that n equals whatever is just where it starts.
Yeah, that's where you're starting your sequence at. Okay. There's some other examples that are pretty good in the text. They do like if you look at example 1 part B, they have the nth partial sum of a series, and they do 1 over n minus 1 over n plus 1, and they show that worked out. And they show how it converges to 1, and then they mention if you do the series of the summation of n equals 1 to infinity of 1, and then you just end up with 1 plus 1 plus 1 plus 1 plus 1, you're going to infinity, so it diverges. So anytime that you're just going off to infinity, just like before, you're still diverging.
Wait. They're diverging here, but you're converging on that little example on your rocket book.
Look, n equals 1 to infinity of 1. If I just do this, 1 plus 1 plus 1 plus 1 plus 1 plus 1 off to infinity, I'm going towards infinity. So I diverge. Anytime you're getting infinity as your location that you're going towards, you're going to diverge. It also could help if I could spell diverge.
Okay. So even though you have like an infinity on top of the other one, that doesn't mean
Right.
you're diverging.
Right.
It's just if it's like going up.
Correct. Like in this case, you're obviously larger than 1, and you're not going towards a specific number. Your numbers just your a sub n values are just growing.
Okay.
So eventually you'd get to infinity. Well, you're going to infinity because your number is so large.
Okay, but if you keep going up, say towards 1, like the other one.
Yeah, then you go to 1 and you converge. Like, think about converging as you're moving towards a certain point. Diverging is like you're just going somewhere.
How do you know you're going to a certain point?
Like here, right? If I go back, my number keeps growing, but like I'm in a fractional form. So I can't get larger than 1. I'm always going to be less than 1. So I'm going to converge to 1. Or there's also like how if you get, sometimes you get larger and larger, like you have 1 in the numerator and then your denominator keeps getting larger, and larger. You're going towards 0.
Okay. I get it now.
Okay.
I have to ask all the questions now because when I'm doing my own homework, you're not going to be there.
No, I mean, that's true. But you guys could just ask me in the Discord. I can always pull up a video call and you guys could join and we could work out problems. Like, that's fine.
Okay.
I don't want to do telescoping. You can look at the telescoping example if you want, but that's not something you'd get tested over. It's interesting, but not something you'd be tested over. Geometric series. So again, something I need to get notes from one of the pre-cal people for, because I think that would just be helpful of understanding how these series are put together. So your geometric series, you have the summation of n equals 0 to infinity, and then you have an a r to the n power. So you have a couple different differences between arithmetic and geometric. Arithmetic means you have like something that's being added or subtracted each time. Geometric means you have a ratio in between. And like I said, I'll try to get those notes for y'all so you can see like numerical examples, because I think that'll help to see how these are built. Plus, then you have a to the r to the n, and then it goes on from there. Dot, dot, dot. Okay, and they give you a rule here, and this rule is important. So I have 2 pink markers. Why are they different? Look at this. Why is there 2 pink ones? All right, sorry.
You might need a different shade of pink.
I guess. I don't know.
Yeah, one looks.
I know
yeah,
they're
one
not the
looks
same,
peach.
but like
What looks red?
no, there's a
One
red
looks
one
peach.
too. I just found it confusing that like the shades are that close.
I kind of like
There's
it.
That's weird.
It is weird. All right.
I don't like that.
So you have the absolute value of r when it's greater than or equal to 1. The series diverges. I'm going to see what the other one looks like. I'm too curious. If the absolute value of r is less than 1, the series converges.
Not less than or equal to, just less than.
Yep. Which, that's the way you want it to be. You want one of them to be equal and one of them not to be. So that way, if you got 1, you know it still diverges.
Okay.
So this is just for geometric?
Yep.
Okay.
Is that the rule?
Yeah.
Okay.
I left out all the other stuff. If you want to look at it, go ahead. But like this I'm keeping it simple and to the point.
I'm good.
At least
Trying to make my
that's the
notes,
goal.
but
That's the goal, at least. So if we have a geometric series, and it is the summation of n equals 0 to infinity of 3 over 2 to the n power, then we could kind of separate this out and think about it a different way. We could think about it as the summation of
N
equals infinity. Sorry, what? My bad, Mackenzie.
Is that 2n down?
Yes, it is. 2 to the nth power. Sorry, that was written kind of small. We can write it as 3 and then do 1 over 2 to the n. Because 3 is just a value in the numerator, we can pull that out. Right? And then 1/2 to the n, any power, 1 to any power is just 1. And then you have 2 to the nth was the other power, so you're fine. Because this would distribute into the numerator and to the denominator based off of exponential properties.
So why do we have to do that?
Because you want to know what r is. Like, you want to know what that r value is, and r is always the power, or whatever has the power attached.
Oh, so you have to make it look like...
Yeah.
Yeah.
So, like, they go in afterwards, and they're like, hey, guess what? Then you have, that's going to be 3 times 1, plus 3 times 1/2, plus ... This doesn't matter. Like, all this extra stuff doesn't matter. You're only concerned about R. All right, and so you could write out the different things about it. Like, we know R is equal to 1/2, and we know A is equal to 3, but absolute value of R is less than 1, so it converges.
Ooh, this is easier.
Yeah, like, you're not having to do a lot of work here. Like, you're literally just looking at R, saying what it is, and then moving on. Are we okay with that?
Yeah.
Okay.
Yeah.
Here's what I'm going to do. I'm going to post a couple problems from geometric that you guys can work on. I might do one infinite, but I'll post a couple geometric ones you guys can try. I'll just attach numbers to that section I posted. And then if we need to talk about them either like tomorrow or whenever, just let me know.
Okay.
Okay. Are we good? We're good for doing tomorrow at 10 instead of 9?
Yep.
Okay. Okie dokie.
Definitely.
All right, peeps. Well, have a